As we've talked in normal stress, the reason that we just use the average of the load over the area is because the variability is only about 4%. And so we can assume that it's pretty constant throughout the bar. There is a point where that's not true. What happens if we do something like add a hole or put a fillet in our bar and we start to take a look at it? Well, what happens at these points is the stress starts to concentrate around those areas. So we can't just take the bar, calculate out the area minus the hole, and then just go, okay, the stress across the area is now this. Because what happens is it does really concentrate right at the edge of the hole or right at the edge of the fillet. So what we need to do is we need to come up with an expression so that we can calculate out how the stress concentrates in those points. Now, fortunately, we're going to see this topic pop up again and again and again for all the different ways that we can apply force, but it's pretty much going to be the exact same thing. So let's go and look at that. And the equation that we use is a fairly simple one, and we're going to use K. And we're going to define K as the stress concentration factor. Now, this is something that I'll show you. We'll be looking it up on tables and stuff. And actually, when you take the lab, you'll calculate this out. So K is nothing more than just the average stress. So you're going to have to calculate that average stress as the denominator under the maximum stress. So typically what you'll end up doing is you'll go, okay, well, I'm going to calculate out my average stress, and we'll box this one, because I know undergrads love their boxes. And so typically what you'll be solving is the maximum stress is going to be K times whatever my, that's wrong, K times whatever my average stress is. So how do we find K? Well, we have to look it up on a graph. And we have different graphs for different situations, so it's always going to be on us to look at the different graph and find out what's going on. And so let's just pull one up here. So this is the graph for a stress concentration with a hole in it. Now what you're going to have to do with each of these is you're actually going to have to take a look at the graph to see what the numbers are going to mean, because they're going to be different for each one. The only constant's going to be is right here along the y-axis you will have your K values. But always along the axis it's going to be different things. Now this one's pretty simple because there's only one line. And you'll notice down here it's like, okay, well, this graph is 2r over d. Well, what's that mean? If I look at the picture here, r is going to be the radius of the hole, d is going to be the diameter of the bar. So let's say something like I have a 4-inch flat bar with a 1-inch radius hole in it. So what would I do? Well, 2 times 1 would be 2, divided by 4 would give me 1/2. I would go to this chart and go, okay, well, here's a half. I'm going to follow it up till I hit the line. And then I'm going to go over and I'll say that's probably 2.15. That looks pretty close to it. And then I just sit there and go, okay, well, what's the average stress across that 4 inches? It's this. And then I'll multiply it by 2.15. And we'll do I'll have a couple examples here so we can see what's going on. But that is pretty much all there is to the charts. Let's look at another one though. So this is a bar with a fillet. This one's a little bit different because we have multiple lines. And so what a fillet is this little radius right here. It's usually from tooling. You're dropping an end mill across the side and you have a radius that's left over. And actually we can see this is how the stress concentrates right at the edge of the small fillet. We're going to have the highest stress. I have multiple lines on here. How do I figure it out? Once again, we need to look at the graph, look at the picture. So each of these lines is labeled by big D over little d. And we can look from the picture. Big D is the larger, little d is the smaller. And then we have the radius over little d. So once again, here's our radius, here's little d. And once again, we just put it together like we would the other. We calculate out, we know which line we're going for. And specifically, we're going to be using this in the example that I'll have up here. So we'll play around more with this chart. And so that's it. Stress concentrations are pretty easy. it's just look up the K value on a chart, use it to multiply by our average load.